everyone, today we will discuss the physical properties of alcohols and phenols. Okay, so two main physical properties are very important for this chapter: alcohols, phenols, and ether. The first physical property is boiling point. Okay, so first of all, we have to discuss the boiling points of alcohols and phenols, and second physical property is their solubility. Very simple. So now we will clearly understand what is the boiling point order of alcohols and phenols. Okay. So normally boiling point depends upon, normally if I will tell you about the boiling point, this boiling point depends upon what? Depends upon the number of carbon atoms. Depends upon the number of carbon atoms. Number of C atoms means carbon atoms. Okay. So due to when the number of carbon atom increases, then the boiling point increases. Indirectly, we can say that when molecular mass increases, when molecular mass increases, boiling point also increases. Boiling point also increases. Clear? Very simple. Okay. So so a main point is what? There is a main point, that is why the alcohols and phenols have higher boiling point as compared to other organic compounds. There are different reasons, but there are two main reasons. First of all is van der Waals forces. First one is called van der Waals forces. Van der Waals forces. Okay. And second is most important, that is intermolecular hydrogen bond. Due to this intermolecular hydrogen bonding between the alcohol molecules, what? Alcohol and phenol molecules, the boiling point of the alcohol and both phenol will increases. Why? Will be more as compared to other organic compounds like our ethers, hydrocarbons, haloalkanes and haloarenes. Let me take the diagram. Let me write down the diagram here and show you what is intermolecular hydrogen bonding. Let me take an alcohol. We all know that the general formula of alcohol is ROH. Yes or no? Let me write here another ROH, then another ROH, like this, ROH, ROH, ROH. Okay, then again another RO and RONH. So we all know that here oxygen is more electronegative. Those element which is more electronegative can attract electron towards itself, electron pair towards itself. So when it attracts the electron pair towards itself, it acquires negatively charged. It acquires negative charge upon itself and causes hydrogen is having positive charge. So causing hydrogen positive charge. So here there is a attraction between oxygen and hydrogen, and this dotted bond is called as intermolecular hydrogen bonding. Okay, so here alcohols are combined with each other, or alcohols are connected with each other due to this intermolecular hydrogen bonding. They are very much attached to each other. Okay, so they must boil, but at a high temperature. First of all, they must break. There must be what? Breaking of this bond. Then this alcohol molecule will what? Convert into gases. So first of all, this bond will break, and then after that, this liquid alcohol will convert it into gas. So due to this intermolecular hydrogen bonding, they were actually connected with each other. Okay, they have strong force of attraction due to this bonding. So when this bond breaks, for the breaking of this bond, we need some amount of energy, we need some amount of heat, and so that's why we have to increase the boiling point. That's why they have high boiling point. Like this alcohol phenols, phenol can show Here is the structure of phenol. This is the structure of what? Phenol. So also phenol can form what? Also phenol can form intermolecular hydrogen bonding. So here also intermolecular hydrogen bonding can be observed. That's why phenol has a higher boiling point. So all these alcohols and phenols have high boiling point, then they have high boiling point than what? Than same molecular mass, means they are isomeric hydrocarbons, ethers, haloalkanes and haloarenes and haloarenes. So I hope it is clear to all of you. So these are the main points which are needed for the boiling points of alcohols and phenols. Okay, so due to intermolecular hydrogen bonding, they have high boiling point as compared to all other isomeric hydrocarbons, ethers and haloalkanes and haloarenes. That means they have a high boiling point as compared to all of these compounds with same molecular formula. Now come to what? Now come to solubility. But before coming to solubility, let me take a simple example to clearly understand when we will take our what? Same molecular mass. Okay. Let me write some example. Okay, let me write ethanol. So we all know that what is the formula of ethanol? CH3 CH2OH. This is the formula of ethanol. Okay, if you calculate the molecular mass, carbon 2, that means C2, this is our C2H5OH. Okay, so it has molecular mass what? 24, then 5, then 16, 30. This is our what? This is our 16. So 46, its molecular mass is 46. Its molecular mass is 46 and its boiling point will be 351 what Kelvin. Its boiling point is 351 Kelvin. This is its boiling point. And let me take another ether molecule. This is our ether CH3OCH3. Clear? Here also its molecular formula is C2H6O. Here also C2H6O. It is also C2H6O. Your molecular mass is same 46, but its boiling point you clearly observe 248 Kelvin, which is less as compared to 351. Again you compare with propane. Propane with formula CH3 CH2 CH3 C3H8 C3H8 with molecular mass what? 44. Normal equivalent 46, this 46 44, 2 mu difference, and which is having boiling point what? 231 Kelvin. So if you compare all of this is hydrocarbon, this is ether, this is alcohol. If you compare all these three compounds, then you can easily say that this alcohol is having higher boiling point, 351 Kelvin. Why? Due to intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding, these alcohols will have more force of attraction between themselves as compared to these ether and hydrocarbons, because they are non-polar in nature. Okay, now come to what? Now come to solubility. Okay, so very simple. Now we will clearly understand what actually solubility is. So solubility means any substance can be soluble in water or not. Okay, so if I will take here ethanol or alcohol or phenols, okay, we all know that alcohols can form what? Intermolecular hydrogen bonding. Here it is, and I will take here ethanol. So let me take another water molecule here, water molecule. Okay, so here you all know that oxygen attracts the electron pair, so acquires positive and negative. So like this, it is also negative, it's positive. So there is just some attraction between the positive and negative charge. So which gives the idea that alcohols are completely soluble in water. If they are not soluble in water, they can't form what? They cannot form this bond. So they can form this intermolecular hydrogen bonding. Due to this intermolecular hydrogen bonding, they are completely soluble in water. So we can say that alcohols and phenols are completely soluble in water. But there is some point. The point is when this carbon chain increases, when this carbon is a non-polar part. Okay, when the carbon is C6, C8, C10, then it will be not getting soluble. Why? Because the carbon is non-polar in nature, the water is polar in nature, so non-polar can't be soluble. So when number of carbon increases, it is not soluble. Okay, so by increasing the alkyl group, these alcohols by increasing the alkyl group or by increasing the number of carbon atom in alkyl group, these are normally insoluble in water. I hope it is clear to all of you. This is all about what? Physical properties of alcohols. Okay, thank you everyone.